Hello, everyone, and welcome to Building Defensive Strategies for Supply Chain Attacks. Before we get started, a couple of housekeeping notes. This webinar will be recorded, and we will be sending out a presentation to all who registered. We will answer questions at the end of the webinar, so if you have any, please type them into the questions box in the GoToWebinar control panel. And now a little bit about binary defense before we jump in. Binary Defense is a managed security services provider and a software developer with proprietary cybersecurity solutions that include SOC as a service, managed detection and response, security information and event management, threat hunting, and counterintelligence. With our human-driven technology-assisted approach, Binary Defense is able to provide clients with immediate protection and visibility, combating and stopping the next generation of attacks that businesses face. Our speaker for today is David Kennedy, and I'll go ahead and hand it over to him to start the presentation.
Awesome. Thanks so much. Let me get my webcam on here really quick, and hopefully you all can see me well. Perfect. Well, thank you all very much for joining today. When it comes to this specific topic, it's one of my favorites because you look at what's happened in the past, not just with SolarWinds, but you look at NotPetya, Stuxnet, a number of other different types of supply chain attacks that we've seen before previously. Now, this is something that's going to continuously evolve. We're going to see more of these types of attacks as time goes on. And one of the points that I'd like to hit on is that you look at the capabilities of ransomware going back 10 years, and ransomware was one of those types of organizations that we would say had low sophistication, really not a major threat to large organizations, and we're kind of a joke, right? They target unfortunately the folks that didn't have very good security. They would target individual people. And what changed very quickly from that business model is that these ransomware groups that were having a lot of success with individuals started focusing on things like research and development, started focusing on weaponization and tooling, post-exploitation, so they can maximize their damage as they're going through and doing things. And so when you look at what has happened with ransomware over the past 10 years, they've taken the same or similar type of approach to nation states, working on their own capabilities, their own tradecraft, their own ways of exploitation, looking at security products and ways to evade them. And with the supply chain attack that happened with SolarWinds, there's a lot of chatter out there in the ransomware groups around kind of the evolution around how do we maximize those types of attacks, where if we can target organizations that are software development companies, managed security providers, software as a services, can we inflict more damage to get a bigger return? So these supply chain attacks are not going away anytime soon. And we have a huge reliance on cloud infrastructure. We have a huge reliance on third-party trusted vendors that do code signing certificates and update mechanisms and things to that effect to our environment. So we have a model where we have a certain level of trust with the partners that we go with. And you look at traditional vendor risk management, it's never been designed to handle the type of supply chain attacks that we're seeing today. So we'll dive into what that means and what we can do defensively to hopefully try to stop these types of attacks in the future. But with that, my name's Dave Kennedy. I'm a co-founder and CTO over at Binary Defense. I've been in the security industry for over 20 years. I started my career off working for the military intelligence side in the United States Marine Corps. Did 2 tours in Iraq. Deployed twice to Iraq for intelligence-related missions. Got out, and I was the chief security officer over at Diebold for a number of years. Caveat: I came in after the voting machine issues, just to throw that out there. And then started my own 2 companies, Trusted Second Binary Defense, which we're global companies, over 300 and some employees worldwide, just focusing on helping organizations get better with monitoring, detection, and getting to earlier stages of attacks to reduce the amount of dwell time that attackers have in their environments, and working with our customers on maturing those monitor detection programs. But I'm on the news quite frequently. I'm on CNN and Fox and CNBC, MSNBC. I helped out with the TV show Mr. Robot. I've testified in front of Congress on a number of occasions, and I've authored a number of open source tools, Artillery, the Social Engineer Toolkit, Magic Unicorn, a number of widely popular tools. I've helped out with the Metasploit project, a number of their exploits and post-exploitation modules. So heavy research centric type of individual, very technical in nature, but also I get to work with some of the largest companies in the world, both from a monitoring and detection perspective, as well as from the offensive side of the house, on the red teaming side, and seeing what's successful, what's not, and also on the incident response side of it, of seeing what's actually happening out there real world. So I look forward to talking through everything today with everybody, and going through really what the problem is on supply chain attacks and what we could do to best address it. But with opening with that, again, if anybody has any questions, feel free to pop them into the chat. I'll get to those. after the webinar itself. But when you look at what we're dealing with today, when we look at threat modeling and how we look at our organizations, most of the time our threat models are really focused on external organizations, hacker organizations, or nation states, or whatever our threat models are, coming in and hacking us in some way, shape, or form, whether that's through social engineering or going after somebody through phishing and going after the endpoints, and then from there moving to lateral movement to post exploitation to get access to other systems to maximize the amount of damage or to get access to whatever data that we need. We have a number of different threats that we have to deal with day in and day out. And supply chain attacks are a lot different in the fact that they take advantage of third-party trusted vendors that we are doing work with. Again, whether that's a managed security provider, managed service provider, someone that we're using from a cloud infrastructure perspective, the data is still sitting somewhere that attackers want to go after, either for monetary gain or for the ability to encrypt. And what's actually interesting about ransomware, just a quick sidebar on this too, is that ransomware isn't just about encryption and kind of devastating your network. There's a lot of ransomware groups that are focusing on data exfiltration as well. So as part of the ransomware, if you have a great business continuity and disaster recovery plan in your environment and you feel pretty confident about your backups, what they're also doing is taking all the data that they get from the initial intrusions and uploading that to the dark web infrastructure, and then auctioning that off, for a certain price to basically either entice you to buy it or others to buy it. And if nobody buys it, they just open up the encrypted volume and give the keys to everybody so that everybody has access to the data. So it's not just encryption, it's not just loss of availability of services, it's also the ability for data exfiltration as well. And so we have a number of these different threats that we have to deal with. And when we look at what happened in taking previous breaches from a supply chain attack perspective into consideration, there's a lot of different variations of these types of attacks that we see. And it really, it's really on us now moving forward to try to look at this forward thinking and say, what can we do to better design our infrastructure, architecture, and how we go about things to protect our organizations in these types of attacks. And so the concepts, behind a supply chain attack really rely heavily off of, a trusted third-party model in some way, shape, or form that has access to your infrastructure. And when you look at code integrity, there's so many different applications that we use on a regular basis, both operating system-wise, third-party-wise, web application-wise, you name it. We are leveraging third parties on a regular basis. If we're using something like Salesforce, for example, and AWS and Azure, we're using Google for Business, we're using whatever cloud providers we want, and then we're also using SolarWinds internally, or third-party package management systems like IBM BigFix or SCCM. We trust Microsoft, we trust Apple. We don't assume every time that we have to update our mobile device that we have to worry about code integrity. So our trust relationships with these third-party organizations goes very far, and we're assuming that they're checking the code as it's going in and ensuring the integrity of that code as it's going through. One thing I can say consistently about doing assessments for organizations is that a lot of times a lot of organizations have been shifting more towards agile workflow, where it's really the kind of the DevSecOps model or the DevOps model. They're trying to get as many features and functionality, bugs and defects knocked out prior to there, but security testing really happens after the fact. So there's not a lot of code scrutiny or investigation of source code or things of that effect actually happening in a lot of the build processes that are going out there, even for large organizations. So source code is a major contention point right now, because a lot of people don't have direct access to that, and there's not a lot of scrutiny going on about what code is actually going into customer environments, prior to the actual build phase when they do the code signing and everything else that happens. But this is definitely one of the most devastating type of attacks that you can see out there, because you look at something like SolarWinds. We'll talk about that, and I wonder how many times I'm going to say SolarWinds throughout this whole series. But when you look at what happened with SolarWinds, there was a large period of time, and it dating back to the late 2019, when one specific adversary had access to the SolarWinds source code and the build process to be able to push updates out to customers, and that wasn't noticed. And there was kind of a stub that was put into the code that was not malicious in nature, but they were seeing, hey, could they get that to execute to specific customers or organizations? And then the March-April timeframes is when the actual attacks in the backdoors and the command and control infrastructure and all that stuff started kicking off. So there was a large period of time where unnecessary code or code that wasn't checked in by any of the developers went unnoticed in that infrastructure. And what's also particularly interesting about that is when you start looking at the Sunburst attack itself, there was a lot of interesting pieces about that. That there was multiple stages of that that were interesting. First and foremost, if everybody remembers the whole shadow brokers, issue that happened with allegedly the NSA and the Equation Group and Russia leaking all of the code for the NSA's Equation Group, which ultimately caused a lot of issues with 0 days releasing and tooling weaponization. The same domain registrar for the shadow brokers group also registered a site basically saying that they were going to sell source code for Microsoft, SolarWinds, et cetera, as part of that. So, we can, looking at the evidence that we have available to us, pretty much without a shadow of a doubt say that Russia was involved directly in this specific type of attack. What's interesting about that is that Russia had said that, well, we weren't the only adversary in here. There was multiple other parties that were in this group already that were part of this specific campaign. And that's kind of crazy. And there's other statistics too that around 70% of the people that were compromised had access to SolarWinds, but 30% did not. So there's some things that were missing here as far as this whole attack, and piecing it together and going back so far starts to become really difficult, because you're talking about going back in logs and understanding things from 6 months to over a year to understand how a specific compromise occurred in the initial entry point. Now, what's interesting is SolarWinds has come out and said, hey, we believe this came from Microsoft's infrastructure, and they were the initial entry point for us. Microsoft's come back and said, we deny that completely. There's no evidence of that occurring. So we still really don't know how they got access into SolarWinds infrastructure, and ultimately, other adversaries that were in there that could have potentially, caused some specific harm. So it's still unwinding, and that's why these types of investigations are really difficult, because you're going back so far, but at the same time, you're having to literally go through a needle in a haystack trying to figure out exactly what occurred, and kind of open this up, and then all the parties that were impacted by it. One thing I could say is that we have done incident response on a number of people that were impacted directly from this specific attack. And a lot of the evidence, equates to not much happening after the command and control was established. There wasn't a lot of there wasn't a lot of things like lateral movement or going after intellectual property or specific objectives. I would assume that there was very specific missions that were going, and the rest of the access was just to see, how deep they could go into an infrastructure to get access to certain things. So, with this specific attack, we're never going to know exactly what the implications or the damages were directly, because it's going back so far. And the amount of companies that were impacted by this, 600 plus companies that were impacted over their 18,000 plus that could have potentially been impacted by this, still really have little to no idea exactly what the motives or objectives were. Obviously they targeted federal government facilities, they targeted Microsoft and Cisco and VMware and Intel and a lot of other organizations that are literally the foundational components of both our networking infrastructure hardware, as well as what pretty much runs the internet in the world. So there's a lot of implications here from this specific type of attack, and these are definitely the types of attacks that nation states want to leverage, because the level of access they had was far greater than anything else they probably could have done directly against one organization or multiple organizations through campaigns. So the time period of this was big, the amount of access that they had was big, and the type of attack for this was really big and damaging. Now, we'll talk about some defenses about this here in just a little bit. But what's important to recognize about all of these specific areas here is that, SolarWinds was one specific snapshot in time. There's also one that I'd like to go back to just a couple of years before that, which was NotPetya. And funny story about, not funny story, it was a bad story. But with NotPetya, I was actually giving a symposium for a group in I think it was Chicago. And right in the middle of my symposium is when NotPetya started breaking out. And one of our customers was hit by NotPetya, and we detected it. And we're able to contain all the systems and move the systems off the network so it didn't spread to the rest. We were able to luckily prevent a major breach just based on behavior detections. Run DLL 32, pulling in something that we haven't seen before, which was at the time perfc.dat, is something that you wouldn't want to see in an environment, especially as it's going across the network. So we were able to contain that and really save that customer. And so it gave us early access to what was actually occurring there. We got a lot of the intel out ahead of time about what was actually happening. But NotPetya specifically was very different motives than what SolarWinds was. With NotPetya, they hijacked the Ukrainian tax software update mechanism, which is very similar to what they did with SolarWinds. They hacked the update mechanism, again, to push out code to those specific systems. And they focused very heavily on automation. And what they did is that they recognized that, and when I say they, specifically Russia, recognized that a lot of those servers were probably going to be running administrative level write type of accounts because they're server type systems. And so what they did is they automated the harvesting of credentials on those systems and the lateral movement components. So what would happen is that it would compromise one system, they'd grab the credentials off of that one system, and then they would start scanning the network with those credentials and keep building up on those. So each system they compromised, they would grab credentials and they would continue moving. They moved throughout the network very quickly. And you look at something like FedEx, I think had like over $100 million worth of damages in just like 17 minutes alone. It was a very fast replicating and very damaging type of attack. And the objectives there were very different. It was a supply chain attack, but it was a very different type of outcome. The whole purpose of that specific attack was to inflict as much damage as possible for anybody that did business within Ukraine. So it wasn't intelligence gathering. It wasn't to steal data or anything to that effect. It was basically straight up ransomware without the ability to pay the ransom. There was a site that they would have you go to pay information, and some of them did pay, but the site went down, pretty much immediately afterwards. The whole purpose wasn't monetary. It was literally to cause as much destruction as possible. So, we see different motives from these specific types of attacks. But one of the things to take into consideration for a lot of these is that now that Sunburst was so successful against a major corporation that had, extremely high level amounts of access. I mean, a lot of these systems were running as administrators or domain administrators, so essentially carte blanche access to almost anything on an infrastructure. As well as having federal, private, and some of the largest companies in the world. These are definitely organizations that, adversaries like Russia, like China, like, that are more hostile on the cyber front to the United States and its allies, are going to be very, very accustomed to going after. And you better believe that, when you look at the evidence around SolarWinds, when the Russians, again, as much as you can trust what is coming out of there, them saying that there was more than one actor in there, would lead you to believe that, hey, there's probably a number of other organizations that are out there right now from a supply chain perspective that have actors in their environment that they don't know about. And so these attacks are going to become more and more common as we go along. And that's the scary part about a lot of this, is because we have that level of trust. It's very difficult for us to do code scrutiny over closed source applications when backdoors are there. It's a very big flaw in our current model today and how we look at things. And so our main weakness in all of this is we trust the code that comes from our vendors. And we should, right? Because we're assuming our vendors are secure. We're assuming our vendors are doing due diligence on their source code, and a lot of times they're not. But these are the things that we're expected to really look at, or we're not expected to look at from a code scrutiny perspective. A lot of times we don't have access to source code. We're not using open source in our environments. We're using closed source like Windows. We're using third-party applications that give us additional visibility. These are all potentially points of access where we really have no control over. So we have to recognize that we have a flawed model in the first place. So that's first and foremost, is we have a flawed model where we can't dedicate resources, nor do we have access to these source code for all these systems to do scrutiny on all of the trusted third parties that we have, including Microsoft and Apple and everything else that we have in our environment. So that's one piece that we have to take into consideration to our threat models when we start to build out how do we best defend against these types of attacks. So we know we have one big weakness, which is the trust factor for third parties. Now, it's impossible for us to say, hey, we're not going to trust any third parties ever again in the future. That's just not going to happen, right? Your businesses need to operate, you need to scale, you need to use this, you need to use that. So we go into this knowing that we have a flawed model and a flawed system based on the third-party weaknesses. So we can work around that though. What's also a key piece of this is it's not just software development, right? And I've mentioned this a couple of times, but it's also managed service providers. It's cloud providers, platform as a service, software as a service, leveraging Azure, AWS, or whatever. These are all areas that we have potential exposures in that we potentially wouldn't have had before in the past if we had done everything on premise. And I'm not advocating that we should do everything on premise. Cloud infrastructure allows us to expand. There's a lot of great things you can do, from asset management to consistency patch management, ease of access, scalability of your business. There's so many great features in things like cloud-centric providers. There's also a risk with that too. And one thing I'll also hit on from a cloud provider perspective is oftentimes if you're moving from an on-premise solution, that's in your environment to a cloud provider, you usually do not have the same or equal, or greater than amount of visibility in your environment as you would on premise. So there's some visibility gaps that we have to overcome from those cloud providers as well. So there's some things that we have to mix and match to figure things out in the future. And again, we'll talk about that. But the biggest area here is the level of trust. What is the level of trust that we have, with these third-party providers, and what does their security program look like? We'll talk about some of that as we go through. and the level of access that this software needs. And we'll talk about your architecture designs and things like that that need to come into play. This one was interesting. There was a thing that came out. So SolarWinds basically said, Microsoft, you were the initial entry point for this specific breach. And then Microsoft came back and said, nope, our systems weren't the entry point for the SolarWinds attackers. Now, what's also interesting about this kind of going back and forth, and this is all understandably, a moving target, right? There's a lot of new evidence that comes out on a daily basis or regular basis. There are things that we have to kind of figure out, as we're doing incident response and kind of piecing the puzzles together. But one thing that's interesting with Microsoft is Microsoft came out, this is several weeks ago, and said, there's no evidence at all that there was any lateral movement post-exploitation, or that the adversaries had any access to any of our infrastructure. And they were very stern on that. And then there was an article that came out from Reuters that basically said there was a major data breach at Microsoft and source code was accessed. That's all it said. And then Microsoft came back and said, no, that's not true. That is completely false. Look at our statement. And then 2 days later, they came out with a statement that said, okay, so they had access to some of our source code, but it wasn't like super sensitive source code. And we did see lateral movement in our environment, but it wasn't bad. So it's an ever evolving story about what we see here. And again, if adversaries have access to Microsoft's infrastructure, core operating system that runs a large percentage of the world, that's a big deal, right? And luckily it seems like it was kind of self-contained, didn't have a large amount of time, but it's crazy. Now, one thing to note about this whole specific thing with SolarWinds, and again, I'll get into the defenses here in just a second. The biggest thing to understand with SolarWinds is that nobody detected this. There was no detections. There was no, when they were using WMI to move laterally to one system to the next, there was no detections from any of these companies. So a lot of these companies talk about, hey, this is how you're supposed to do detection in your environment. I'm not singling out any one or the other, but the detections weren't actually what caught this specific type of breach. What caught this specific type of breach is that when the adversaries went after FireEye, there was an employee in FireEye that got a weird message saying his two-factor, him or her, I'm not sure, that their two-factor authentication password or the two-factor authentication token had been reset. And they thought that was weird and they reported it. And then from there was an investigation launched and then it blew up the whole SolarWinds case. So it wasn't a monitoring and detection capability. It was an employee that actually took this whole thing, a nation state going into 600 plus environments that really caused this whole thing to really unwind. So it's a big deal to look at what happened in this specific case, and can we learn lessons from this that could have identified this earlier on in the attack cycle. And that's our ultimate goal, right? We have moved away from 10 years ago where our whole model was we were going to create a heavily fortified castle that was going to protect our entire infrastructure. That's just not possible anymore. I mean, with BYOD and work from home and cloud infrastructure and everything else, we're using large cities now at this point in time, right? And so our whole goal now isn't to protect against everything. And don't get me wrong, we still want to focus on protection and all the good stuff that comes out of that, vulnerability management and stopping the basics and hardening and MFA and everything else and security architecture designs. But at the same time, we recognize that we're never going to be 100% secure in any way, shape, or form. It's not possible. So how can we identify an attack in our environment as early as possible, in the earliest stages as possible, and remove the amount of time an attacker has in our environment? So instead of them having 6 months in our infrastructure, they only have 1 day or 2 days or 3 days. I'll take an hour or two of an attacker in my infrastructure and be able to respond to that. Then 6 months would they have access to everything else in our environment. So how do we whittle that down? How do we shrink down the amount of time that we have in an attacker's infrastructure when an attacker's in our infrastructure to respond much more effectively? And that definitely comes down to detection, but there's also a lot of other things we need to look at as part of this. So let's talk about a little bit of the breakdown of defenses that happened here specifically. First and foremost, insert a backdoor, which that part there, again, as I mentioned before, is a flawed design in how we trust our third parties, right? We're not going to be able to fix that. Now we can do things like vendor risk management and go into those organizations, and if you have a right to audit in person, especially if they're critical vendors, there are ways for us to go into those sites and to investigate how they're doing things. But ultimately, at the end of the day, are you going to know if an adversary that has unlimited funds and resources hacked into this company, hit their build process, they didn't detect it, push out updates to your infrastructure, and all of a sudden now they have maintained access to your environment? That's probably not going to happen, right? From a vendor risk management assessment. I'm not saying you shouldn't do those and you shouldn't look at an organization's security structure to see if they can, potentially withstand those types of attacks or be able to respond to those specific types of attacks. But it's important to note that most likely you're not going to get to that level of detail or be able to really see that type of thing happen in an environment where you're using a third party. So we know that code is going to be an issue. We know that potentially managed service providers, have we looked at their infrastructure and architecture? Can we minimize that to what they actually have access to? Cloud service providers, same thing. Vendor risk management isn't necessarily going to get to that level of detail as we go through. Again, we could write to audit, go in person and see them, especially if they're a critical vendor. But at the end of the day, an inserted backdoor into code is going to be something that is going to be very hard for us to find. But some things to consider as we look at defense and really where a lot of the breakdown started to occur, and we'll start to talk about some of this in a little bit more detail. This is just high level at this point. But architecture design to me is the biggest piece. When we look at threat modeling towards our organization, a threat model exercise is, and I'll talk more about this in detail, is really looking at who your adversaries are and what you need to build into place to try to protect against them, both from a preventative and a detective perspective. And how do you upkeep that and maintain that over time as things change over time? You hear this term a lot, the tactics, techniques, and procedures of attackers, or TTPs. The tactics may not change as often, but the techniques and procedures absolutely can. And so how do you stay up to date and relevant with those specific threat models to ensure that your infrastructure can withstand those over time? And that really comes down to understanding your adversaries, but also designing your infrastructure, not just to focus on outside in, but also inside out. When we usually design our infrastructure and architecture, it's usually to prevent hackers from breaking in. But what in the event that if a hacker gets access to that infrastructure, do they have access to the rest of our organization too? So SolarWinds is a great example. Did that account really need to be running as a specific privileged user? Could there have been things that we limited, for example, ports and protocols going egress out from those servers, the Orion servers themselves? Could we have limited things to just SNMP and other things to minimize the amount of access those servers actually had to our infrastructure? So getting more to what we consider more of a zero trust model of things, where you're not just protecting against your infrastructure, you're minimizing ports and protocols and ultimately your attack surface. But zero trust really relies very heavily off of trying to protect against users, being more of a service model provider for your users. It also needs to look at what happens in the event that you have these third-party applications that are in place, making sure they're using the least restrictive model and making sure that they don't have access to the rest of your infrastructure and architecture. Now, one big key thing about architecture in this specific case that really blew my mind, and it was honestly really frustrating to hear a lot of these large organizations and companies that they didn't do this, is when you look at the actual attack, okay? When SolarWinds was popped and they put the code into SolarWinds, the Orion platform, and they pushed those updates out to those select individuals or select companies to get remote code execution in the March-April timeframe. What they did is they essentially pushed that code down. Code would execute on those servers in the affected company's server infrastructure that has SolarWinds Orion performed. And then what would happen is on that server then beacon out to the internet and then automatically register a unique domain name. And there was a formula that was used for that. That's how you're able to kind of predict who was impacted by this. But what ended up happening is it would go out to the internet, register a domain name, and then establish a connection, to the attacker's systems, a two-way communication. So the big piece there to understand that really would have made a huge difference in protecting these companies is not allowing your servers to communicate with the internet in the first place, especially systems that it hasn't before in the past. That is like security basics 101. And those are one of the things that you have to absolutely focus on from a server infrastructure perspective. If the attackers didn't have access to command and control infrastructure, those systems were safe, even though they're running those malicious artifacts that were pushed out to them. There's no command and control. There's no way to execute code. So you literally would have taken this massive potential breach and shrunk it down to a big nothing burger, because there's literally nothing there for an attacker to exploit, because they can't communicate back and forth to send instructions to laterally move across your environment or to go after other systems. So while they had an update mechanism, they didn't have the ability, if you shut off the access to systems that haven't already previously before beaconed out to the internet before, or just completely disallowed servers from communicating out to the internet in the first place, would have completely shut down this entire attack first and foremost. So, not allowing your server infrastructure to communicate out to the internet, or only putting in exceptions into place for systems that that it needs to, for update mechanisms and things to that effect, or if using package management software like SCCM, leave it to that. Don't allow them to go out to the internet. That's one big important piece there that I can't emphasize enough that would have shut this whole thing down from the very get-go. Pushing updates out through an update mechanism would have stopped this specific one. Now, I want to say that it would not have stopped the NotPetya specific attack, because all the code needed for the damage that occurred in that specific area was done through that perfc.dat, which is downloaded through the update mechanism, which then spread out. They didn't need to go out and beacon out for command and control for that to happen. But that was a very specific use case where it was destructive in nature in every way, shape, or form. They wouldn't have been able to establish a C2 if they had that component in there. Now, one way to stop that is looking at your egress rules. Do servers really need to communicate from server to server to server to server to server? If you have an application that is running and it's specifically dedicated to that, it may need to talk to domain controllers. It may need to talk to very specific systems or databases, but does it need to talk to your entire network as a whole? Shrink that attack surface down, create smaller network segments those applications live in, and stop the spread of lateral movement and post-exploitation from that. Do your servers really need to be in a server infrastructure farm that can communicate with everything else that's out there? Now, don't get me wrong, there are servers that may need access to communicate to other servers for things like patch management or vulnerability management or other things that you have in your environment, maintenance and things to that effect. So maintenance, subnets, server subnets that have direct access. There's going to be use cases that there's exceptions that need to be put in place. But as a whole, a lot of these applications don't need full access to your entire network. And refining that and going down to a system that allows you to reduce that scope makes you a lot more secure down the road, again, especially against these specific attacks. So that's architecturally talking about it, right? Behavior on systems is a whole another area around how you protect against these types of attacks. Now, if you look at the post-exploitation scenarios that a lot of these adversaries used, or that Russia specifically used in this, when they got their command and control in the system, that's ding, 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 number one, that's a bad thing to see a server beaconing out to a system that it hasn't before in the past. But second, when we look at if you look at something like the MITRE ATT&CK framework and a lot of the different types of attacks they have through the different attack chains. So you look at things like initial access. What happens after initial access? Well, we have things like privilege escalation. We have post-exploitation methods, lateral movement, exfiltration of data, et cetera. So we have all these different phases that go on after an attack. And these are things that we really need to look at our server infrastructure for, that's commonly only applied to our workstation environment. For example, in this specific case, the Russians use WMI very heavily to do a lot of things. Now, WMI has been used by the Russians since I can't remember how long. It's been years and years and years. This is a common indicator across the board, especially WMIC being executed. Servers are something that don't change often. Now, don't get me wrong, you have updates, you have packages and things like that you push through. But as a whole, the behavior on those servers should be pretty consistent across the board. And so looking for things like WMI execution is definitely an area to focus on. Things like PowerShell exploitation. Why is PowerShell being leveraged when it hasn't before in the past? Looking at things like parent-child process relationships. Why is this parent now spawning child processes of this when it hasn't before in the past? I'm a huge advocate of things like Sysmon, for example, which give you a substantial amount of visibility. It's a free tool from Microsoft, Mark Rusanovich's team in sysinternals that really has a ton of data that you can pull from your server infrastructure that gives you a lot more indicators that could be potentially happening in your environment, that could give you some early warning indicators as these things happen. Now, there's a difference between commodity attacks. Commodity attacks are the things that we see all across the time, but then there's attacks like this where we're not necessarily going to see it. So what can we look at or key off of that happened after the fact that this initial access occurred that isn't going to be covered in our EDR products or anything else? That's really looking at the behavior of those systems. That's why it's really important to have both of those types of coverages. You want to look for things like encoded command or invoke expression, or things for PowerShell exploitation where they're using syswall64 downgrade attacks, or they're using process injection with create remote threads or process hollowing techniques. Those are all things that we would want to see from an attacker, injection into LSAS for Mimikatz and stuff like that. Those are predefined attacks. Well, what happens when we don't see those? And that's really where you start getting into the behavior in the systems, what exhibits those on the server infrastructures themselves. And that's a whole different level of monitoring detection, right? We have to evolve as a security industry to get to that type of place. Next on the list is network segmentation, which I kind of covered a bit, but this also goes for workstation environments, and this is where we start getting into the zero trust model. Now, the zero trust term is such an overly broad term. There's products out there that claim that, hey, they can, get you to a zero trust model. Zero trust is more of a discipline within your organization. It's not a product. Now, there are products that can help you with certain areas, like especially if you're looking at like VDI environments or sandbox and virtualization or application publishing. You're looking at something like Okta storefronts or Citrix or something to that effect. There are ways to minimize giving people the full application stack of your environment as well as full ports and protocols, like you would a VPN. So, zero trust is an architecture design. It's a methodology. It's a way of looking at your environment and saying, we don't need to provide the traditional access of the past to our users. We can become more of a service-oriented, organization and rely very heavily off of web applications so that you're using those. Or if we don't have the capacity to do web applications, virtualize those types of applications so that they're not actually running on those specific systems. So you're taking the user out of that, and what you're doing is you're taking your attack surface and you're shrinking it down so that if an adversary has access to one system, it doesn't create a massive data breach across all the other systems. And that's the biggest area that we see for most customers, is that one person ends up being the largest downfall of the entire organization. And that's really the problem, right? You don't want one person becoming, the entire cataclysmic downfall of an entire organization. That's what we see time and time again. So those are all things to consider as we talk about, the breakdown of defense. Now, I want to show you something right here, and this is a demo, and this is one I did recently. This is I think like a week or so ago. And a lot of the tools that we use for preventative mechanisms don't necessarily work in these types of attacks in any way, shape, or form. And what's interesting about, something like, you look at how this attack worked. A lot of the security vendors came out very quickly afterwards, like, oh, we totally would have detected that if this would have happened. None of the vendors were detecting this. Even the malicious DLLs, the lateral movement, even the indicators of compromises that were happening afterwards. The EDR products were not firing off in those specific commands that Russia was using in those environments. So, and I can attest to that, having done incident response for those organizations. But we were largely blind. At least a lot of organizations were largely blind to this specific type of attack, and that's really where we have an over reliance on the products that we use. And what I want to hit on with this is that the security industry tries to automate as much as possible, and I understand that because people and time investments in getting skilled people is a very challenging thing in this industry. But one of the things to note is that most of the technology that you have running in your environment today is trivial to get around from an attacker's perspective. I mean, absolutely trivial. So if I'm modifying an attack in some way, shape, or form, or I'm manipulating in some way, shape, or form, I have the ability to get around that almost instantaneously just by rewriting something or changing something easy. Now, what I'm going to show you here is a demo of Windows Defender. And this is not Windows Defender ATP. The ways to get around that is a little bit different. In this specific case, it's very different ways of looking at things. So Windows Defender has what's called integration into AMSI, or the anti-malware scan interface. And with AMSI, there's what's called an Amsi Provider, which is basically, a way to hook into scripting languages like PowerShell or WScript or CScript, macros, things to that effect, and it'll scan that process memory space. It has a hook in there for AMSI to DLL, and it'll scan that process memory space to see if there's anything malicious in there. And this is one of the tools that I wrote called Unicorn. It's an exploitation framework for PowerShell. And I just want to show you how easy it is to get around just Defender detections based off of this. So we're going to go ahead and run the tool. And I'm going to check my IP address really quick. But I'm going to run the tool. And what this is going to do is it's going to create a payload for me that's going to create an interpreter shell through Metasploit and have it connect back to me as the attacker. Okay. And what I'm looking for this is to somehow get execution some way in shape or form on a system that can execute my PowerShell through macros or through a downloader on the web, whatever we want to do. And in this specific case here, the first part of this payload is what we call an AMSI bypass. Now, AMSI is so broken in every way, shape, or form. And what I mean by that is AMSI to DLL gets imported as a regular user context. And so as a attacker, I can simply just disable AMSI, or I can shut it down or have it not scan my process memory space in the first place, which means that it never gets submitted to an AMSI provider, which means that it never gets detected at all. So in this specific case, this first one here is a AMSI bypass from Rasta that I've rewritten so that it gets around AMSI, it gets around the AMSI detections that are in place through Windows Defender. And so what we're going to do here is we're going to decode it really fast. So I'm just going to get to its raw PowerShell code, which is a little bit more obfuscated. but we're just going to print it out so that I can work with it to test to see whether or not it's getting detected by Windows Defender. And whether I'm using a Defender or EDRs, the ways that we go about this is very similar in nature. It's literally about understanding what their signatures are and then kind of modifying it, appropriately. So we're gonna go to my Windows machine here. We're using the PowerShell interpreter, the IC. We're gonna hit play, and notice here at the very bottom it says script contain malicious content. What's happening here in this specific case is that AMSI prior to submission is scanning this saying, hey, does this match any of our signatures for something that we've done before in the past? And Windows Defender is still very much just predominantly a signature-based detection tool. Regardless of what they say that is in there, it's primarily a Windows a signature-based detection tool. And so what we're going to do here is we're going to take a look at this and say, well, how can we break this up a little bit to figure out where the detections are? And this is literally just a cat and mouse game of taking your code and modifying it and playing around. So what we're going to do here is we're just going to change the bytecode in here, just to which is B8, and we're going to change it to yo-yo, just as an example. And we're going to do a replacement back here, down here, to replace yo-yo with B8. So all we're doing is just splitting this up a little bit more, so that our bytes in here, our shell code that we're going to execute, ends up being split up so that when it goes to scan this, and it's literally doing a scan string, so AMSI scan string, it's scanning this to say, does it match B8, 5, 7, whatever, 7, whatever these. And I notice I have some obfuscation already kind of built into here already that they're detecting on. So it's just modifying this just a little bit to get around it. And we go in and play this. So notice here, malicious content detected. And notice here, when we run this, we now get true. It no longer gets detected. It's running the latest version of Windows Defender. And if you go into this section here, the only thing we turned off is we turned off the cloud delivery so that the cloud delivery doesn't actually execute. So what that means is that we've just disabled Windows Defender's ability at all to scan anything that we're executing. So anything that we execute is not going to be scanned anymore. And we now have full access to execute whatever we want to without having to worry about being picked up. And it's that easy. Literally took me a little bit longer to explain it, but usually it's about a 3 to 4 minute process to get around those specific areas. So when we look at these types of things, and I have a couple more slides here, and then I'll get to some questions. And there's a lot of questions out there. So again, feel free to answer questions as you go along here. When we start looking at threat modeling, we have to look at our entire environment. And it's not just Windows, it's Linux, it's OS X, it's everything that we deal with within our organization that makes our technology. And we have to build threat models associated with that to not only protect against outside in anymore, it's also inside out. And when you look at risk, risk is always the big elephant in the room, because we look at risk differently across organizations. But when you boil it down to its simplest form, risk is going to be very much based off of likelihood or impact to the organization, and likelihood and impact to the organization. And likelihood is the hardest thing to determine within an organization, because you say, well, how likely is it that SolarWinds is going to get hacked, and that we're going to get an update pushed to our infrastructure, and then it's going to be Russian hackers, and they're going to have access to our infrastructure? That's a low likelihood threshold that we would have considered before in the past, but it happened, right? And when you look at the chatter that's happening with ransomware groups right now, you look at the chatter that's happening across the board around, the concerns from DoD around supply chain attacks, and how these are going to be kind of the next wave of attacks from third-party adversaries, APT groups. Supply chain attacks are going to become much, I said much too many times, but much more common. And so we need to start building these into our threat models. It's not just outside in, it's also inside out. So our design of our infrastructure architecture really needs to be like that. And cloud infrastructure can really help with that, by the way. Moving to something like Azure or AWS, you can really get refined on what your applications and your systems have access to talk to. You can really start to get into network segmentation very heavily in a cloud-centric environment that allows consistency across the board. I'm not advocating move everything into the cloud, just telling you those specific areas are important. And that also goes for on-premise as well. Modeling your infrastructure to be resilient against outside in as well as inside out. Those are big, important pieces there to really try to restrict access in the event that any of the systems become compromised. It's also not just about the preventative mechanisms and threat modeling, it's also about detection. How can we get better at identifying things earlier in the stages to be able to boot those attackers out, or to launch an investigation to understand what's happening in an environment? And to me, some of those areas there is threat hunting. I think threat hunting has always been the largest missing link in many organizations. You look at traditional security operation centers and monitoring detection. A lot of times companies will basically grab a SIM, they'll enable the defaults that are out there, and then they're just worried about regurgitation of alarms. So you get an alarm that pops up, you have a SOC analyst that looks at it, 99% of the time it's a false positive. They move on, they go to the next one, they go to the next one, they go, oh, we found one here. That's not an attainable state to maturity within your security operations center. A security operations center needs to be continuously looking at threat intelligence. They need to understand what adversaries are doing. Those detections need to continuously increase. And you also need to be going through the data. There's a talk I gave a number of years ago. This is when I first got into information security, well, let me rephrase that, into the private sector on information security. And it still holds true today. I gave a talk with a joint presentation with a guy named Ryan McFarland from the FBI. And him and I talked about, taking the long tail, which is more of a business model of understanding economics and applying that to information security. And when you look at the long tail of a lot of attacks and you apply that to the data that we have, you're going to have a lot of noise up here. But as that tail starts to go down, you can start to look for unusual indicators in your environments you haven't seen before. Like, why is Bob in sales now executing command line syntaxes like who am I, or net users, or things to that effect? Why are these services being created when they haven't been before? Scheduled tasks, etc. So there are things that we can start to look at by going through the data that we have and figure out ways that we have where we don't have visibility into our environment that we need to add. So to me, threat hunting is a really big important piece there of looking through your data, looking through your logs, and assuming that there's a potential attacker or adversary in your environment, and going through those exercises on a regular basis through your teams. I think that's really important from a detection standpoint. It also directly correlates back to putting your detections up to a whole different level and continuously optimizing them as things go along. Any type of implementation that you do from an architecture design, as I kind of hit on before, needs to incorporate the threat models of looking at network segmentation, least privileged access, user accounts, giving them the least amount of access possible. Those are all key important pieces there. From a logging and detection perspective, there are so many things that we can key off of that are unusual. But again, it's a noise ratio, and this is why the behavior piece is a bit hard at first from a work perspective, because we want to, let's just say we have an EDR product that we're using, and we assume that that's going to have a large percentage of detections. Well, it does to some extent of known TTPs, but it's not specific to our environment. It's not usually, it doesn't understand our environment in any way, shape, or form, and our environment is unique than anybody else's that's out there. So when you start to shrink, you start to look at other things in your environment that you want to start focusing on. One of my big areas for looking for things is parent-child process relationships, Markov chaining. So this specific parent process spawned this child process, which spawned this child process, which then was ultimately used for code execution. Parent-child process relationships are some of the most fruitful areas, and I'll sit there all day long looking through parent-child process relationships as a way to identify things. So those are key pieces there that I would heavily recommend focusing on. Command line arguments, process creations, process interactions for like process injection as an example. WMI is a whole other area that a lot of people are very blind to when it comes to being able to detect those specific areas. Server-to-server communication, trying to minimize that server-to-server communication is another big piece there. So again, all of these areas that we can start to look at from a monitoring and detection perspective can really start to help us as we go along. And again, combining that with threat hunting really starts to make that big difference. But with that, I'll start opening up to some questions here. I know we have a few here, so one second. So question, is there a better way to log WMI other than Windows events or Sysmon? I would say Sysmon's probably going to be your best bet for WMI. I know people are scared about Sysmon, especially as it's like another agent. One thing to note about Sysmon is it is produced by Microsoft and Mark's team over Mark Rusanovich's team. It's a very low footprint. It runs at about 4 to 8 megs of RAM, so it's super low, 0.01 CPU usage. And what's nice about Sysmon that people get scared of is the amount of data that you're putting into there, right? If I enable Sysmon, especially in its default configuration, it's gonna be a substantial amount of data that you probably need additional licensing for. What's great about Sysmon is that it's very configurable to only log what you want to. So the Sysmon configuration file allows you to exclude as much as you want to, so exclude things that are noisy, include things that you want to, and you can do and or statements. So and this or that, then trigger something. You can also put alarm details in there, map those to things like the MITRE ATT&CK framework if you want to. But for WMI specifically and WMI exploitation, Sysmon's probably the best route to go from a detection perspective. There are ways of doing querying for WMI, but they can't have performance sits on your system. There are what are called intrinsic and extrinsic type of WMI queries. A lot of those have performance hits out there for the system. I'd say the best would be to get to ETW or event log tracing for Windows through Sysmon. It's probably going to be your best way of getting WMI queries through that system, unfortunately. But once you actually go through the criteria of Sysmon, there's some great references there. You have Olaf's Sysmon modular, which is a great starting point for configuration. Swift on Security also has a great Sysmon configuration. There's already some great starting points there, so you're not starting from scratch. Our sister company, Trusted Sec, also has the full deployment guides for Sysmon and how you kind of deploy it across your environment. Even Microsoft references ours as being kind of like the de facto standard for what you want to do for Sysmon. So take a look at that too. It can help you with getting WMI queries through Sysmon itself. Had another question from Aaron. What Linux flavor is that in the tech demo? It's just a modified version of Ubuntu. I came from kind of a Debian background, so Ubuntu kind of fits with me as I go through, and I pretty much use my own custom distribution. And for my tools and techniques that I'm using, I typically use a tool that I wrote called the Pen Testers Framework, which is a way to install modular way to install all of your tools that you want to use for pen testing or red teaming or things to that effect. So I'm very specific on the tools that I use. And I only install them for when I need them, and I kind of remove them afterwards. So I use a tool that I wrote to kind of keep me through that methodology there. Someone asked, Joseph had asked, can you expand on the relationship between MSSPs and clients? Is the reason they seem to do such a poor job a function of the client not providing necessary info, the MSSP not asking for it, or something else? That's a good question. When you look at what's happening from an MSSP perspective, the discussions that typically happen aren't necessarily the least amount of restricted access possible. An MSSP is going to want as much access as possible to be able to do their jobs. And typically the customer is going to want to give that amount of access to their jobs, but there's never a discussion around what is only needed in order to perform your job. So ports and protocol minimization, least privileged access to those systems. And constant communication is also a key piece from a relationship perspective. It's not just hand things over. It's also working together to figure out that relationship as things go along. It's not that MSSPs are doing bad. It's just that interaction between the two organizations is kind of a pairing. Oftentimes the communication is the biggest challenge there. So biggest piece there is one thing to focus on as things go along. Is there a threat hunt list you can share common hunting activities that your analysts do on a daily basis? Common list. I know that on the Binary Defense blog site, as well as our sister company Trusted Sec, we have a number of different posts on what it constitutes to conduct threat hunting. I know we have a threat hunting service, obviously, from our side of the house. We can help with that on. Our threat intelligence team does a great job of coming through and going through those exercises. Those are key things that you can kind of go through when you're looking at threat hunts. The key piece there, first and foremost, is visibility, and then the second part of that is starting to comb through that data of what you're actually looking for. So those pieces there are all really important to take a look at as you're going through, and then starting to build your criteria based on your environments. But starting off, DNS, north to south, east to west traffic, PowerShell, command line auditing, Kerberos, process creations, service creations, scheduled tasks, WMI. Those are all going to be some very quick hit items that you can go. Well, not quick hit. There's a lot of data there. Those are a lot of things that you can go through initially as you're starting to conduct those as you go along. Aaron said Olaf's Sysmon config is great. I completely agree. I'm a huge fan of Sysmon modular and big fan of Olaf itself. Lucien had asked, given the fact that code has flaws from which most are built from C, do you recommend pen testing any software from any third-party vendors? Yeah, I mean, when you look at actually conducting assessments against your third-party applications, that's going to primarily find potential exposures or flaws within those applications themselves, right? Not necessarily backdoors that were placed, although there's the potential for that. We've seen it before in the past, but it's not necessarily going to detect adversaries that have been potentially on there in the first place. So some of the key things to focus on there is that you definitely want to assess or look at previously assessed applications in your environment, especially if they're critical to your business, housing sensitive data, externally exposed, et cetera, et cetera. Going through frequent testing is really, really important to go through and really kind of model yourself off of that. So, I think it is important to test that frequently and to go through those specific areas, but you also need to recognize that, hey, you're probably not going to detect a Russian backdoor inside of something like SolarWinds. That's getting down to a very myopic level in there. But looking at the patterns that application exhibited, registering new domain names and things to that effect, if you have been monitoring DNS and looking for patterns in your servers, that definitely should have shouted out to you in that without having to do a full code review over the specific areas. But definitely some good questions and appreciate those. But wrapping things up here, before we get off, it's not just an inward outward or outward inward approach. It's all of the above. Our focus has to be incorporating threat modeling to our organizations that incorporate these supply chain types of attacks and to try to minimize this as much as possible. Believe me, as I say it here, it's 2021. By 2023 or 2024, maybe even sooner, we're going to be talking about the first ransomware breach that occurred from a major provider of a software tool or a platform as a service or a software as a service, and thousands, if not tens of thousands, if not hundreds of thousands of customers are going to be locked out of their infrastructure. And it's going to happen. They're weaponizing their tooling as much as possible. They're getting more sophisticated as things go along. You look at last year, you look at some of the major data breaches, Universal Health Systems and Garmin, and they're starting to target very large organizations based on the sophistication that they have. So this is going to happen. It's just a matter of whether or not we're prepared to minimize the amount of damage to our organization, and whether that we view this as one of our biggest threats. And it absolutely is from a damages perspective. Right now, again, from a likelihood or probability, do we have a better chance of a hacker phishing a user and then from there using post exploitation? Most likely. But the damages themselves are going to be substantially lower in consistency to what we see from these type of supply chain attacks. We have to focus on both. And how many supply chain attacks are there right now that we don't know about, that are already out there, that we haven't seen, that haven't been disclosed yet, that we're going to be reacting to? Again, this is going to be more of a common theme as things go along. Mark my words here today. I've been right on a lot of other things. I said PowerShell before it ever got released was going to be one of the major front of attacks, and it was. I spilled my water. But these are the types of things that we have to focus on as an industry to get better at. And our models right now, based on how we trust our code, are definitely flawed in that. But getting better with monitoring detection, focusing on those are all going to be key things that we hit on. But I want to close things out and say thank you all very much for hopping on and being a part of this webinar. If you have any questions, feel free to reach out to us anytime. I'm at Hacking Dave on Twitter. Obviously, we have our Binary Defense Twitter. You can hit us up at binarydefense.com or email us at info@binarydefense.com. Always available to answer your questions. If you're looking for a company that does managed detection response or monitoring detection, we like to stay vendor agnostic on a lot of things. We also have our own tooling and ability to do that, threat intelligence and everything else around that side. So great company to work with, that partners with you to get a lot of good things happening in your environment to help against a lot of these types of attacks that we see out there. But hopefully you learned a couple things. Feel free to reach out to us anytime. And thanks again for having me.